hypothesis test example 1. This is with a two-sided alternative hypothesis. Okay, so here's our example. In one Florida election, 40% of all registered voters voted. A research studying the behavior of academics was curious about whether political scientists voted in the same proportion as the rest of the people in the state. To answer this question, the researcher took a random sample without replacement of 54 political scientists who live in Florida and interviewed them to determine whether they voted in this election. As it turned out, 40 of the 54 political scientists in the sample voted. This gives us a sample proportion of 0.74 or 74% of the political scientists voted. We're going to carry out a hypothesis test to determine whether the proportion of all political scientists who voted in this election differed from the proportion of the general public. Okay, so step 1 is to hypothesize. What does that mean? It means state your null hypothesis and alternative hypothesis. In this case, our null hypothesis is that the political scientists vote in the same proportion as the public, or at a rate of 0.47. Now, our alternative hypothesis is that the political scientists vote in a different proportion as the public. So what does that mean? It means that if the H0, or the null hypothesis, is P equals 0.47, then the alternative hypothesis is that P is not equal to 0.47. So this is how we write both of these hypotheses in our special notation. Now, just a quick note before we move on. This is a two-sided alternative hypothesis because we're using a not equal to sign right here. So if it was greater than or less than, it would be one-sided. Okay, step 2 is to choose the significance level and check the conditions. So we're going to let our significance level be 0.05. That's our standard. So if you're not told one, then you can just let it be that. If you become a scientist at some point in your life and you have to do this stuff, then you'll learn more complex methods of how to think about how to choose this, but this is sort of like a typical one. Now, in terms of checking the conditions, we'll do that on the next page, which is actually just this slide. So our first condition is random sample. So in this case, we're told that the data come from a random sample of 54 political scientists. So you can see within the text, it says the researcher took a random sample. And so we satisfy the first condition. So condition 2 is large sample. What does that mean? It means we have to figure out what n times p naught is and what n times 1 minus p naught is. Now to do this, we need to know what is n and what is p naught. Well, we're told that the number of political scientists that we interviewed is 54, so our sample size is 54, that's what n is. And then p naught, that's the proportion of people that we already know have some quality. So it's our null hypothesis p-value. In this case, we're told that 47% of all registered voters voted, and so p naught is 0.47. So I think the number one mistake people make maybe with this kind of thing is they mix up p naught and p hat. So p naught, it's not the one that comes from the sample, and so p hat is the one that when we took the sample of 54 and we got 40 of them voted, this is p hat. P naught is sort of the typical standard null hypothesis, what we already know or think is true value, 47%. Okay, so if we multiply these, we get 54 times 0.47 is 25.38, and then we also get 54 times 1 minus 0.47 is 28.62. And so what are we checking here? We're checking that both these numbers are bigger than or equal to 10. And so 25.38 is bigger than or equal to 10, and 28.62 is bigger than or equal to 10, so we satisfy condition 2. This is how we measure a large sample. Okay, now condition 3, large population. For large population, we need to check what 10 times n is. So 10 times 54 is actually 540. And we just have to know that this number is smaller than the number of all the people of interest that we could have taken when we did our sample. So when we picked 54 political scientists in Florida, we were working within a whole population of political scientists who live in Florida. And when we randomly selected those 54, we selected them from a huge group of people. So what we're going to do is we're going to assume that there are more than 540, this number, political scientists in Florida, because the idea is that this number that we get when we multiply 10 times n, it has to be smaller than the total population of political scientists in Florida. In other words, our population has to be big in compared to the sample that we took. Okay, so that's an assumption we had to make. Now, independence. So the final condition we have to check is that the observations are independent. We assume that because the researcher used a random sample of political scientists, their responses were independent of one another. In other words, we didn't have multiple people taken within this group who were like best friends or a married couple who might have opinions that are more likely to be the same. Or they didn't chat with each other before they did the survey. So because the conditions are verified, if the null hypothesis, that the proportion of all political scientists who voted is 0.47 is true, then the sampling distribution of the one proportion z-test statistic is normal or approximately normal and modeled by this normal curve. This means we can move on to step 3. So we're done checking the conditions. So what is step 3? Step 3 is we're going to find the observed value of the test statistic, or z, and the p-value. Now, we can do this on StatCrunch, or we can do it using a combination of StatCrunch and by hand calculations. So first I'm going to show you guys how to do it by hand and with StatCrunch. So we'll do a combo. Then I'll show you how to do it with just StatCrunch. But to start, we'll do by hand and with StatCrunch. Okay, so how do we do it this way? You start by finding z using these formulas. So we use this one and this one to find z. Second, we're going to use the normal distribution on StatCrunch or the normal tables from Appendix A to find the p-value. So how do we do step 1? We're finding z using these two formulas. In other words, I'm going to plug in p0 and n into my standard error formula. Now we saw earlier that p0 was 0.47 and n is the number of people in our sample, or 54. So if you type that into your calculator, you get 0.0679188 right here. And then we actually use this number to find our z, and z is given by p hat minus p0 over standard error, which we found in the previous step. Now p hat, that is our sample proportion that we get when we take the sample of people and see how many have equality. So we looked at a sample of 54 political scientists and we found that 40 of them voted. So p hat in this case is going to be 40 divided by 54. If you type that into your calculator, you get 0.740741. Then we subtract p0 and we divide by standard error that we calculated in the previous step. If we do that, we get 3.99. Okay. Second, we can now use this z value of 3.99 to find p. How do we do that? If you want to use StatCrunch for that, you can go to Stat Calculator's Normal, and then use the normal model with mean 0 and standard deviation 1 to figure out what p is. So what I'm going to do is I'm going to get out of full screen, and we're going to follow these instructions to go Stat Calculator's Normal to figure out what p is. So I go to StatCrunch, and I go Stat Calculator's Normal. We did this a while ago, and here's our familiar normal model here. Now we're going to use our standard normal model, which means the mean is 0, standard deviation is 1. And then we got our z-score was 3.99. And then we can use that to calculate a variety of probabilities. In particular, we can find the probability that our proportion is less than or equal to 3.99 or bigger than or equal to 3.99. Now, I'm going to use bigger than or equal to 3.99 because that's going to give us the area. You can't even see it on here because 3.99 is such an extreme z-score, but it's going to give us the area underneath this curve and to the right of 3.99. So it's area underneath this and to the right of 3.99. Now, if we do that, we get 0.00003304, and we're going to hold on to that and go back to the slides. Okay, so we actually just got 0.000034 here, 3304 here, and that's actually the area underneath this curve to the right of 3.99. You can't even see it, it's too far to the right. And for a two-tailed p-value, or for an alternative hypothesis that has a not equal to sign in it, we're interested for our p-value in not only the area to the right of 3.99, but the area to the left of negative 3.99. So the area to the left of negative 3.99, it's actually the exact same as what you see here. So if we want to know the total area underneath here that you can't even see because it's too tiny to even shade, we would be adding up area to the right of 3.99 plus area to the left of negative 3.99, and those are both the same as each other. They're both 0.00003304 because of the symmetry of that shape. If you add those two together, you get your p-value right here. So for an alternative hypothesis that is two-sided with a not equal to sign, you have to add these two together. It's a little bit more complicated than the other way, than a one-sided. Okay, so this is our p-value. Just because I wasn't able to, on the previous picture, show you guys very well what I meant by the shaded area, here's a picture of what I mean by the shaded area. So if our z-score is 3.99, we're shading everything to the right of it, and then if it's negative 3.99 over here, you shade everything to the left of it. So we're interested in what this area plus this area is. On StatCrunch, we were only able to find one of them. Okay, now if you want to do this just using StatCrunch, if you find that a little bit easier, here's what you would do. You would go stat, proportion stats, one sample with summary. Then what's going to happen is a box that looks like this is going to pop up. And you guys are going to have to fill in number of successes and number of observations. Now, successes is how many people have the quality of interest that you're looking at. In this case, how many people voted. And then number of observations is your end value, or how many people you interviewed. Then we're going to select hypothesis test. And you're going to fill in your p-value. So in this case, our p-value, it's the p-naught value, and our p-naught value is 0.47. And then you're going to fill in if is it a not equal to, is it a greater than, or is it a less than for your alternative hypothesis. In this case, it's we're interested in the probability that the proportion of voters who were political scientists who voted was different than the whole population. So it wasn't greater than, it wasn't less than, so we're using not equal to. Okay, I'm going to show you guys how to do that. We'll exit full screen and do stat, proportion stats, one sample with summary. So we go stat, proportion stats, one sample with summary. And then we observed 54 people total, and 40 of them said they voted. And then our hypothesis test, p-naught was 0.47, and then this is a not equal to right here. And then we can just push compute, and out pops a bunch of info. So what is this information that we get here? A couple of interest, Z stat, that's our Z score that we found earlier. It's 3.99 if you round it. That's what we got earlier. And then it says p-value is less than 0.0001. It doesn't actually show you the exact p-value. It just says that it's smaller than 0.0001. So we're going to hold on to that and go back to the slides here. Okay, so this is what popped up. Now, what does it mean that p is less than 0.0001? It means p is a super, super, super tiny small number. It's so small that they don't even tell you exactly what it is. They just say it's less than 0.0001. Now, we actually know exactly what it was because we calculated it by the other way. But if you do it just via StatCrunch, like I just showed you, it's just going to sometimes it'll tell you it's just p is really small. So how do we interpret this? Well, step 4 is to interpret. In this step, what you do is you compare the p-value you got to your significance level. So you take your significance level and your p-value and compare them. Now, if p is less than or equal to the significance level, you reject the null hypothesis. If p is greater than the significance level, you do not reject the null hypothesis, or you say that there is not enough evidence to reject the null hypothesis. There should be a closed parentheses right here. Okay, so in this case, our p-value was 0.00000066, or using just StatCrunch, we got it was less than 0.0001. In either case, it's less than 0.05. So we do reject the null hypothesis. Our interpretation then would be, we conclude that political scientists did not vote in a different proportion than the rest of the population. Wait a minute. Let's pause for a second. Okay, so I actually just misread that line, so you guys will have to just pretend you didn't hear that. And so we conclude that the political scientists did vote in the different proportion than the rest of the population. I thought I wrote the wrong thing for a second there. Okay, so if we reject the null hypothesis, that means we don't think that it was like 40% of the political scientists voted just like the rest of the population. Our p-value was so small that we think that they must have voted in a different proportion, or the political scientists must have voted in a different proportion than the rest of the population. So the probability that they did vote at the same rate is pretty low based on what we saw here.